All right, so I'm going to walk you through this problem just like I did the first AP problem we did together. One note, if you took a picture of my answer key in class, there was a small mistake that I made that I found in working through this for you guys for this video. So the first thing you have to recognize is I just got attacked by a Twix. Oh my goodness, cat. Go, shoot, go that way. Okay, so the first thing you need to know how to do, right, and fairly successfully, is recognize what the formula of these things are. So the first thing that I talked about was hydrochloric acid, and the formula for hydrochloric acid is HCl. And then the thing that we were adding that to was barium hydroxide. Barium has a +2 charge, so barium hydroxide formula looks like that. Then we're going to predict the products. Barium will bond with chlorine, right, and the other product will be H2O as a liquid. This is aqueous. And though I didn't say in class, you are safe to assume that all of these are aqueous as well. So now I need to balance my equation. There are 2 chlorines here, so I need 2 here, which also then increases the need, or rather makes it necessary, to put in front of the water. And then I'm just going to do the limiting reactant problem just like we did in class. So I'm going to start with 46 milliliters of hydrochloric. And we know for every 1,000 mils, there's 1 liter. And we have the molarity. And I know for every 2 moles of HCl, I have 1 mole of barium chloride. Now, you just as easily could have gone to water. I simply didn't because I wrote barium chloride first. So if you went to water, your numbers are going to be different, but your final conclusions should still be the same. When I plug this into my calculator, I get something that looks like this. And then I'm going to do the same thing, but from barium hydroxide over to barium chloride. So I start with 96 mils. Same conversion, 1,000 mils to a liter. Now I'm going to use my new molarity. And the last one wasn't necessary. And this is in a 1-to-1 ratio, so for every 1 mole of barium hydroxide, I've got 1 mole of barium chloride. And you plug that into your calculator, and you get 0.017472 moles of barium chloride. Now you'll notice I'm not rounding. I don't want to give myself that problem of serial rounding, so I'm going to wait for sig figs till the end. So of these two, this is my smaller number. So we'll make hydrochloric in red, that's my limiting reactant. Barium hydroxide in blue, I've got that in excess. And hopefully you remember the question that we're trying to ask is how much, or rather what the concentration of our excess reactant is. So the next thing we need to do is figure out how much of our excess reagent we've used up. Well, if this is how much product I can make, I can start there and work my way backwards to figure out how much of my barium hydroxide I actually needed. So I'm going from here to here. For every 1 mole of barium chloride, I've got 1 mole of barium hydroxide. So these numbers are going to be equivalent. Now, if you could look at this and see that they were 1-to-1, this is not a step that you would necessarily have to write. I would make a statement, however, that you made this conclusion based on the fact that it was a 1-to-1 ratio. So from here, this is how much barium chloride I used. No, this is just, found it. We're no longer talking about barium chloride, talking about barium hydroxide. All right, so this is how much barium hydroxide I used. My barium chloride's canceled out. Now I just need to figure out how much I had to start with. And that, again, you can go through the whole calculation again, but right here, you can recognize that barium chloride to barium hydroxide is a 1-to-1. So this is also how much barium hydroxide you started with. So I'm going to take the amount that I started with and subtract from that how much I used. And I will be back with your answer. So I'm back. I'm going to make one tweak rather than re-record 5 minutes. There should be an 8 here. And that leaves us with 0.009514 moles of barium hydroxide left over. Now, the problem does not ask about barium hydroxide. It asks just about the hydroxide ion. So here I have to do a conversion step that I didn't have to do before. Okay, this is how much barium hydroxide I have. For every 1 mole of barium hydroxide, there are 2 moles of the hydroxide ion, right? And when you double this number, you're left with 0.019028 moles of hydroxide left over. But again, that's not what the problem asks you for. So I'm gonna, continue to scroll down. The problem asks you for the concentration. Concentration is molarity, which is moles of solute over liters of solution. I know the moles, 0.019028 moles. And I also know the liters, right? Here's one part of the solution. Here's the other part of the solution. When you add those together, you get 142 milliliters, which is 0.142 liters, right? I do the math there in the calculator, and I'm left with 0.134 molar concentration of OH minus. Quick check in on sig figs. I've only got 2 sig figs in either of these numbers, so I'm going to round it one last time to 0.13 molar is our concentration for our OH minus ion, which is in excess. There you got it.